This is the top of the board and this is the base of the board, right? Is the base of the board is moving at 1 inch per second. Is the top of the board is gonna go down 1 inch per second. Do you think that's reasonable? If we're moving right 1 inch per second and top board is gonna move 1 inch per second? What do you guys think?
Yeah.
You think so?
Mhm.
How many people think so? Raise your hand.
Actually, no. I need more.
Why?
I don't know. I just feel like it. I changed my mind.
Why do you change your mind? What's the reason that change your mind?
Because, like, it wouldn't go down at 1 inch per second. It's like this is moving forward. It would go down like, I don't know how to explain it. It's just like visually, I don't think it would go down.
Okay. Danny, what do you think?
So as the board goes down, it's gonna go like this,
Yep.
and it'll hit flat at the same time. So I think it would go down.
Yeah, but so if we go down 1 inch per second,
Yeah.
this is gonna go down 1 inch per second. That's my question.
That's not a square board, so.
Wait, how are you pushing the board?
And let's just say I pull the ball like this.
If it's
Oh,
like 20
then
inches.
yeah,
Looks really
It's gonna be the same?
yeah.
So you think the same? Is anybody think different? Raise your hand. You think it's different? So Reebok think different. Anybody else think different like Reebok?
I kind of feel like it would. Like it doesn't.
I see that.
It seems like it would move less at the top and it would at the bottom. But I don't
What's the question?
know
Joe,
how to explain why.
I think it's because it's a rectangle.
Yeah, that's what I
Yeah,
was
I mean
saying.
the
Because-
length.
Well, the top also moved.
I think
down
so
the
they'll
way.
go down slower.
Will the top move
Maybe.
down 1 inch?
No, because then if it goes, if it's like 20 inches tall and it goes out 20 inches, it should be flat, right?
Yeah.
It should go down an inch.
Okay,
That's a
so
good idea. But for red.
how about this? We do an experiment to see what happened. Because a lot of time, like people don't understand. Like the truth of the answer is probably everybody has the wrong answer. It can be the same. It can be different. It's all relative. Okay. So it's very unique situations. So let's just say if I'm start at 10 inch, right? And we don't want to do a 10 inch, we don't want to move the board at 1 inch per second. We just want to move 1 inch. Let's just say move from 10 to 11 and see how far it go down. Is that okay? Okay, so we're gonna go pencil. Anybody have pencil? Okay, so we're gonna do it here and we're gonna do it here. So we're gonna start at 10 centimeters. And then we're gonna do an experiment. So this is an experiment. So as first, we're gonna have a 10 here. And then we're gonna draw this at 10. Okay? And then we're gonna move exactly 1 inch and then see how far it goes down. Okay? So let's move exactly 1 inch. So let's just say 1 second later. How far it go down? Do they go down 1 inch? It's going down like almost 3/8 of inch. Do you guys see that?
If it was a square, it'd be the same.
Yeah.
Okay, so that's from 10 to 11. That's from 10 to 11. So I move from 10 to 11, it go down only this much. Okay? Now let's go to the next part. Which next experiment I should try? Should I try between 15 to 18? Which number you want to try?
16.
Let's go with 16, go. So let's say 16. Okay, so 16. And then I'm gonna move exactly 1 inch again. So this is 16. And I'm gonna move exactly 1 inch. So if I move down 1 inch, slightly wider.
Is it like exponential?
So it's exponential, I don't know, but it's wider than before. Before it was 3/8 inch, now it's actually 3. Before it's 3/8, now it's about 3/4. So this is 3/8, and this is 3/4. Okay, so 3/4 inch, a little bit greater. Okay. What's the next number you want me to try? Let's say between 24 to 27. Which one you want me to try?
27.
25, okay. Well, 25 is a nice number. So let's say 25. Okay? 25, this part is 25. And I'm gonna move exactly 1 inch. How far it go down? Much greater than 1 inch now. So let's look at here. It's going down 1.5 inch. So what Rebuff said is the only one that's more correct than the other. But it turns out all you guys are correct. Before we have 3/8 and have 3/4 and then moving to 1/5. Oh no, sorry, 1.5 inches, right? 1.5 inches. So you got 3/8, 3/4, and 1.5. Somewhere in between, you guys are correct. And that's called intermediate value theorem. Does that make sense? Intermediate value theorem says if you go into 3/8 and 3/4, somewhere in the middle it's gonna go exactly 1. That makes sense, right? So we apply 2 theorem in calculus. Then not just a related rate. So related rate is a relationship between this height and this width on the bottom. It really depends on that. So it's related to each other. Related, there's only 2 things, 2 dimension. One is y and one is x. Okay, thank you.